Okay, so welcome to the Node.js N-API Team meeting for September 9th, 2019. We'll follow our standard agenda, which is to go through the things which are tagged for the current milestone. I'll just pull that up and share it. Issues. Okay, so the first issue which was tagged is building add-ons with CMake. I did tag it so that we could have some discussion with Jim, since he's done some work, I think he mentioned, with like one of the tools that lets you build with Make. So I'm going to suggest maybe we just skip until the meeting when he's available. Okay, if everybody agrees, then the next one is N-API feature suggestions to consider. Okay, I think that one's actually been answered, so I'm going to untag that from the milestone. Okay. And I think I'm going to close it. Okay, do we need additional async worker variants? I think that one's still open in terms of we have an issue where, you know, we would actually add in some variants to match, which is what is in NAN. And I believe actually even that we have a PR which we're working, if I'm remembering correctly. Right, so our pull requests. Right, so the Legendus CAS is actually working on implementing the async process worker. There's some discussion back and forth. And there was a PR that was blocking this, which I landed a few days ago. So I think work is continuing on that one. Okay. Any comments or questions from anybody else on that one? No, okay. Flip back here, oops. Right, maybe here. The workshop. So I guess the news that I heard was we have added Jim to the workshop, which is good, as one of the leaders. I also know that there's been some work ongoing on the workshop itself. Does anybody have anything to add on that? I don't have the specifics.
I think Jim was working on a new tutorial last I checked, if I remember correctly.
Yep. Yeah, I know he started to work on it already. So, okay, we'll wait till when we have him, or I think Nicola was working on it with him too. So we'll wait till they're back. Investigate future breakage. I don't think I've seen anything there recently. I know Nicola's still working on the, which one was it? It was the iConf port with Ben, but I don't think that's landed yet. Haven't heard anything new from Jim on the SQLite port. And in terms of issues, like I said, there was a couple issues opened and that I landed recently in Node add-on API, but nothing too new, I don't think. Have either of you seen anything else new that's of note?
I haven't checked honestly, because I was working on the weak reference callback cleanup hook tie up,
Okay.
and then the small thing that's sort of a prerequisite for that, but I haven't checked on the issues. If I remember correctly, there was either a crash or a leak at some point.
There was in Node, there was the issue opened around leaks with functions.
Yeah, exactly. Yeah. That seems to have been sort of passed off to V8 though, because
Yes.
I think you established that even function uses function template internally.
Yeah, and I did some experimentation that basically, you know, I cut it down to, so here, this is the issue. I cut it down to just these 3 lines of code, and it still seemed to be seeing, at least if that's the increase that was being reported, I still saw the increase go up. So yeah, I guess we're still hoping. I pinged them a couple times to see if we can get somebody on the V8 side to either suggest that we're using it incorrectly or help us figure out if it is an issue on the V8 side or not. On the Node add-on side, there was an issue still that's still open on. Oops.
Node add-on API.
Yeah. There is still the issue related to this one. The object wrap destruction. So that one's still been out for a little bit. And it could use some time. I haven't had a chance to go look at it. I think it was basically the fix broke one of the earlier versions. So we'd have to figure out what to do in that context.
Okay.
I'm wondering, like I haven't had I wanted to try and take a look late last week, just didn't quite get to it. I'm wondering if we can, like, you know, if we didn't see people complaining about it in earlier versions, you know, is it something where we can guard the code so that it only does the new stuff for the later versions, right, where people are running into it. But anyway, I don't have enough context yet to make progress on that one.
There's an open issue on thread safe functions, and I think it would be worth just a while to discuss those.
Sure. This one, question about threads?
No, 524.
Okay.
Yes, it's kind of similar to how somebody pointed out the limitations for async worker.
Right.
Yes, this guy, he pointed out some issues with thread safe functions. And I think it would be beneficial to sort of go through these and maybe make a plan of action.
Yeah, it's a great idea.
You know.
Okay.
Yeah, I kind of looked at that briefly, and from reading it, my first impression was that some of these things are issues in Node add-on API, whereas others are in Node core. So.
Right. Okay.
Yeah. Why don't we go through them and we could sort of say that. So most for the specific selecting a copy constructor.
And his use case is fair, I imagine. But yeah, there is no copy constructor. And I think that in the implementation, there's like a unique pointer that the wrapper class has for the N-API thread safe function. So I think that may disqualify it from having a proper copy constructor, if I'm not mistaken.
Sorry, let's now open up the code node. Here, I'll just navigate and then you can point me. So this is it probably a N-API INL, right?
Yeah.
Thread safe.
Thread safe function.
Okay, thread safe. Right, okay, so here.
Right, and I guess also in the declaration of the class might be helpful too. So in .h. So this wrapper class has private, like a unique pointer to the N-API thread safe function.
Yeah, right here, towards the bottom there.
2061.
Yeah. Oh, this one, right?
Yeah. But the person's use case makes sense, but I don't know if the current implementation would allow a copying of this. And I'm not really sure what the best solution is.
Yeah, because I mean the core thread safe function can be copied ad infinitum because it's just a pointer. So yeah, that's yeah. I don't know how we can pass those semantics on to the class. Yeah, my impression from the beginning was that it's going to be kind of hard to wrap this because you know, basically you cannot really provide that much value, you know, by wrapping it, because you know, any sort of logic that you add that seeks to provide value is going to have to be thread safe itself, and so you're essentially building on top of the thread safe function instead of just exposing it, you know.
Right.
That was my initial impression, but okay, I guess we did get this far, and it does kind of work, but I guess it can't cover all the use cases that the core thread safe function can cover. So I don't know, maybe what we need is we need a constructor that takes an existing thread safe function, right? I don't know, do we have one of those that just, you know, it takes whatever it has and goes with it instead of a constructor that
Here, let me flip back to there.
yeah, that it always creates one.
I think we do.
So you're looking for like a constructor for thread safe function, or for the
for thread safe function, which takes an existing N-API core thread safe function.
There's this one here, thread safe. That's not a thread safe function other.
Yeah, no, we just have like the factory method.
1987.
Okay, here's another one. Yeah, here's a constructor for it.
Yeah, I should have it in this screen I'm sharing right there.
Yeah.
And then do we have a way to, if you have a Node add-on API thread safe function, can you get its underlying N-API thread safe function?
Yeah, I don't know if we have that, because all the value classes, they all have like a casting operator, so you can like cast to a regular value. But you know, that's just it, right? Like if the class stores the thread safe function in a unique pointer, I don't think we can simply cast like that, because we're probably violating the semantics of the unique pointer at that point, you know. Which is also, because I mean, essentially we'd be doing a copy operator behind the back sort of thing.
Right.
So yeah, I don't know how to go with this one, because like we'd almost need like a lighter version of a thread safe function when you build using an existing one. Like I don't know what happens when you build using an existing one. If you can't get it, then it doesn't really matter. Because I'm thinking like, you know, if you can't pass like a thread safe function class instance between threads, then at least you can pass like the core one. But then first of all, how do you get it on the main thread? And second of all, is it safe to sort of construct an object with it on the secondary thread?
Hmm.
And is
Yeah. Because the
and
thing is fundamental, right?
we need a
If
copy
we,
because we're not, like, we can't pass, I guess different threads, they could have a pointer to the same instance of the class, right? Or the,
yeah, that's what happens in core. That's what happens in core. It's a plain pointer, right? And it's an opaque structure, so, but it has pointer semantics. Exactly. But the thing is, right, like, fundamentally, if we pass a pointer to a thread safe function class, to an instance of a thread safe function class, which contains a pointer that is the core thread safe function. Now you got to manage. Now you got to manage the life cycle of the pointer to the class instance, right? And and so you need to sort of, I mean, you do have pretty good management because you know, you create it when you create the thread safe function, and you destroy it during finalize. So you have a pretty good uh, cover for it in that sense. But then it would have to be a pointer. So then, you know, I don't really see why we need this whole unique pointer thing, right? Because it's thread safe by virtue of the fact that thread safe function is itself a synchronization mechanism, right? So by the time finalize gets called, you can rest assured that there is no contention for the pointer. Nobody's going to ever access the pointer ever again because all the references have been released. You know, so if we wrap it in a plain pointer, then I don't see why that would be bad. You know, except of course, well, yeah, I don't see why it would be bad to do that. You know, and then I think we can go with a copy constructor and all that if we just use a plain pointer. But then I'd have to check why we started using a unique pointer to begin with.
right, so where's the deleter? The deleter is just says, basically that, okay, that was recently added.
Yeah, the deleter was recently added. But I think the unique pointer was added because when we were constructing it, like when we would say, I think it was due to the, when did it come up?
Here, I can do a history of that. Not sure if we'll have this straight.
It was because if you had an existing thread safe function, an existing variable that was holding a thread safe function, and then you would say TSFN equals thread safe function new again, sort of like overriding it. I think that was causing problems.
Oh, yeah.
Ending up needing a unique pointer for that.
Oh, I see.
In order to, yeah, because there's like an error message, like he has to check if it already holds one. But I don't know why he needed to.
Oh, okay. Yeah. But is that the solution though, right? Like, do we need a unique pointer to check that? Because, you know, the assignment itself can be controlled, and we can like error out. We can check the private methods of the variable, or can we? Right? I mean, an assignment like that, like, you know, TSFN, where TSFN already holds a valid one, equals new da da da. That results that's not a simple assignment, right? That results in code being executed. At which point we can check whether you're trying to overwrite like a non-empty thread safe function. Can we not?
Well, would it be valid to have one of these instances having a pointer to a N-API thread safe function that is no longer valid? Because like after Because say that we were using a regular pointer that would allow us to copy the instance then, but now we would, after the thread safe function is finalized, we would not necessarily we wouldn't be able to clear out our pointer, would we?
Well, we would, because there is a finalized callback, right, which tells you, listen, you know, the thread safe function is over, so you better clear out. And at that point, we could set the pointer to null. Like we are being informed that the underlying object is no longer in existence.
But
so I'm thinking that you.
But how would that finalizer clear out all of the copies of the instance? Because if you've created multiple copies of your thread safe function instance, it needs to be able to clear out all of those references.
Yeah.
And
yes,
that's not
true.
And I'm not sure how that would happen.
Okay, so when you make a copy, yeah, you basically you would have to have like a list of all the references and
well, but how about we could go the other way?
You do have an opportunity to maintain that list, right? Like when you make a copy, then you know you add the location to the list of locations that need to be nulled out. But I guess that's what a unique pointer does, probably, right?
And I think that sounds like a lot of overhead that we're adding.
Yeah, the other way would be maybe to have this point to, like, if all the copies pointed to a common object that held it, then you, at least if you cleared it out in that common object, it would affect them all. Then you'd be down to, like, when can you free that common object, right?
Yes, and then the common objects, that would be freed in the finalizer when we create the thread safe function.
Yeah.
Yes. I think that...
well, yes and no, because the common object cannot be freed until all the copies are somehow released, right? Because the common object just holds the thread safe function, but it is not itself the thread safe function, right? So if you delete the common object, now you have the same problem as you did with the core thread safe function. How do you update all the references to say that the common object is gone?
But I would say you potentially could do that through a reference count, right?
Yeah, you would have to go with the reference count.
Every time there's a copy, then, and I don't know if, like, a smart pointer could just do that for us. Either basically a reference count of some sort that basically says, okay, this is the last instance which is on the stack, therefore I can delete it. The only issue, I guess, is because there's multiple threads, you might need some synchronization.
Yeah. Yeah, that's the issue. Well, actually, yeah, you need synchronization with the ref counting.
Yeah.
But you wouldn't need synchronization with the deleting because you would like all, you know, the finalizer informed you that all the threads are gone, right? So there are no more threads that are actually doing the deleting.
Well, if you know that, like, do you actually know, like, because when we want to delete it, does that mean there are no more threads that are, like, they basically all ended, right?
Well, they at the very least promised never to access the thread safe function again. Whether they ended or not, we cannot say. But for all intents and purposes, yes, they did end.
Well, in that case, couldn't we just delete the common object there?
Well, no, because although the thread safe function has been deleted, right? References to it may be left over in the code, and all those references have now to reflect the fact that the thread safe function is gone. So, you know, they must return like invalid or closed or whatever for as long as they are still within scope. allocate it.
Okay, so they haven't promised not to use the wrapper.
Yes, the threads have promised not to use the thread state function, but we don't know what's going to happen with those variables that hold copies of it. You know, but yeah, I don't know how far we can push these semantics, right? Because okay, yes, they cannot call things like, you know, like a call or async or what is that called? You know, blocking call, non-blocking call. They cannot call those functions anymore. They promise not to call them, but you know, there may still be like instance methods that, you know, that they can call, you know, and so I don't know if we can delete the underlying uh, reference counting mechanism.
What
I don't know that
methods would they be calling?
Well, let's find out.
Yeah.
But yeah, I mean, you're right. I mean, if there are none, okay. So let me see. Where is the header? See what methods this thing has that might get called.
I have it open on the screen on the share. If you.
What are trying to see here?
Basically, there's a point where they've basically said, you know, you can no longer use the thread safe function.
Mm-hmm.
And if at that point we can be sure that they're never going to use the class, then we could delete internal pointers or whatever, you know, do whatever we want, right? And I guess the concern is, Gabriel was thinking maybe they can still call some of the methods even though they've agreed not to call some of the main methods. But I'm trying to understand then, well, what would it be that they're calling?
Get context is one thing. Well, okay, but no, they can't call get context because get context is basically boils down to N-API get function.
I thought the only thing that you could possibly call if the thread safe function is closed would be an attempt to make a call, and then that call would return closing.
Well, but after the finalizer, there should be no more calls which can be passed through the core API.
I think that is any. Yeah, I don't think you can after the finalize, because after finalize, you're no longer guaranteed that object even exists, right? I remember something like that being said on the docs.
Yeah, exactly. So, I mean, yeah, maybe you can't. But then, what do you do with those variables, right? Like, are they just going to go out of context, or what? You know, like.
Sorry, which variables?
Like the ones which are of type N-API : thread safe function. You know.
Well, those will potentially, but isn't it that the threads, like they may go out of scope, but you should not call anything more after you should make no call on those after the thread has basically said, I'm not using you anymore, right?
Yeah.
Mm-hmm.
Yeah. So the last call you make is whatever variable holds your instance dot release, and that's it. After that,
so after you've called release, you better not call this again.
Yeah, or if you call like blocking call or non-blocking call and you receive N-API closing, then again that's an indication that you must not call it ever again. So that's the other
check non-blocking.
So then, yeah, the variable should go out of scope, so that should not be a problem.
Colin. See, like, but maybe this call internal needs a guard or something, right? Because Because if you're saying you can call non-blocking and it tells you that it's closing, I guess you would call this, it tells you it's closing. As soon as you get as soon as you get that, you should never
Right. You
call
would
it
handle,
again.
yeah, you would handle it in our code, yeah.
But you don't need to call a release after that?
No.
Like to say that you're done too?
You do not.
It basically assumes that if you've made any call, then you know.
Correct.
Okay, that I could understand. So it does seem like that and I think we have a destructor, like the thread safe function allows us to destruct something as well, right? When it's finalizing?
We do have like our finalized callback that we run.
Right. So exactly, but so that, okay, so the finalized callback, right. We run that on behalf of the creator, right?
Correct. So when you say thread safe function new, I have the ability to pass in a finalized callback.
Yep.
And then that gets wrapped into here. But then what we do is delete the instance there.
Right. And so that's deleting.
I just noticed a small problem.
Right.
It's completely independent. We are assuming the instance was allocated with new. We're making the same mistake as we did with the async.
Right.
We shouldn't be calling delete here. We should have like an instance method which is responsible for deleting the instance.
Yeah, that makes sense to me too.
Yeah, so that's a bit of a problem.
Oh, okay.
But even so, on a copy, it would delete, because this is for the wrapper. Like if you made a copy of this, you don't want to delete do you want to delete the instance and run the finalizer? I'm not sure. I don't think you'd want to rerun the finalizer.
Yeah, I don't think you would want to run the finalizer again. Like line 57, no, you wouldn't want to do that again, because that's like calling what I provided.
Okay, we're not deleting the class. We're deleting the data that was passed.
Yeah, I guess instance, the finalize here is just a convenience it basically exposes the finalizer, right? So this instance arrow finalize, this just exposes the finalizer because that's part of the API, right? And it's part of the underlying API. So we're just passing that through, right?
Right,
Yeah.
it's deleting
genuine action.
Right, that's deleting not the instance of the class, but the instance of the data that you've provided that you want.
This is not thread safe function. This is object wrap.
Ah, okay.
It's like what?
Okay, so let's see. Right, thread safe.
Okay.
Wait,
do I need it in? This is the INL, so is this still part of it?
Finalize. Yeah, I think it's a little low, a little down. Let me search here. Node finalizer. Do a search for wrapper with data and context.
Okay.
It's on line. Oh, yeah, I could give the line. 3969.
Okay, that's way up high.
Wait a second. No, thread safe details, thread safe finalized.
Actually, I got to go back to looking at the actual. I was doing a blame of an old thing. Let me go back to the.
Okay. And I think it's line 154 on N-API Inl. Yes. In the Inl, N-API inline.
Okay, so, right.
Yes.
Sorry. Oh, what happened to my? I somehow closed that.
Line 140 on my version.
$140. Okay, right.
Yeah. So we have this.
Let's say finalize. Yeah. Okay.
Mm-hmm.
So when you create it, you can create a finalizer that gets run and pass in some data, and that data would be destroyed. That makes sense. And then we probably want one, as long as, thread safe finalize, I assume is thread safe finalize. I'm just seeing where do we, okay. Finalize data and wrapper, okay. Finalize data. Where do we pass in the function be called finalizer? Okay. I guess the finalized data bundles in the finalizer, right?
Correct.
Okay, so
because the finalizer is, I think, just like the thing that reads all of the data,
right,
and everything. Yeah.
Okay, so it would know when to delete that shared object. Because at that point, nobody should ever make another call to the wrapper classes.
Right, because any of the copied ones, they would have either called release or made a call and got closing. Every single copied should have done that before the finalize would have ran.
Right, because the copy will have to ferment.
Oh.
That was weird. You guys hear that ringing?
Yeah,
Where that's coming from?
that might be his mic.
Michael, can you still hear us?
Hello? We can know. Well,
now?
hello? Yep, we hear you now.
Okay, I'm having some trouble here. So like I was just saying, every copy made and basically effectively incremented the reference count on the thread safe function.
Mm-hmm.
Yeah. That makes sense, Gabriel?
Yeah, I think so. Yeah, it's starting to look like all those different copies. They basically don't worry about like the life cycle of it. Only to pass straight through to core and API, and that's it. So and by the semantics of the thread safe function, I don't believe there should ever be a situation where you're going to call from a secondary thread and you're going to sec fault because the thread save function was destroyed on the main thread. That should never happen. Because you would have been alerted to that by either an API closing, a return of an API closing, or you would have done the release yourself. So
correct.
So that should never happen. So yeah. And I was just thinking, like, if the C++ instance, like this NAPI : thread save function, if you pass that as a pointer into the secondary threads, then as long as everybody does acquire and release appropriately, then there should be no problem again, right?
Yeah,
you just delete the finalizer and that's it.
And do we even need an intermediate object? Can we just delete? Or like, I guess it's like that TFSN, it doesn't even need to be cleared out, does it?
Well, no, yeah, that's right. Yeah, because I mean, you would delete. Yeah, if we pass the C++ instance around as a pointer, then there is no issue of a copy constructor, right? Because you're just passing a pointer, and we don't need to do any ref counting because the finalizer happens exactly once and on the main thread. So that's taken care of. The only thing we need to worry about is that when we call the finalize callback, it is very likely that that's going to delete the instance inside of which we are playing. So if we want to, we should avoid nulling out the pointer at that point, and we should stop making references to member variables of the instance. That's the only thing we need to worry about at that point. So basically, make copies of all the variables that you need from the instance inside the scope, and then call the callback, finalize callback, and then just use those variables for whatever. So it's the same thing that we had in an API core with like the async worker, where we deleted the async worker, and then we were using the environment stored inside the async worker, and that was causing sec faults. So we need to be careful with these things in this case.
But in this case, can the finalizer call the delete on the TFS, like the TFSN? We started with where was it? The unique. Why am I not finding that? Okay. It's got to be in there. That's right. Or no, it's in the other one. That's why. Okay.
It's in the 8.
Unique. Like, this doesn't delete anything, right?
No, and it shouldn't. It shouldn't, because you don't actually need to, like the TSFN is yes, it's a pointer type, but nobody manages the lifecycle of the pointer except an API core. So there's nothing to delete. It's just a pointer.
So could that not just be a regular pointer? All the copies have a copy of it, but that's fine because nobody needs to delete it.
Yeah, I'm not 100% sure what the deleter class, that new deleter functionality was added for.
I think it's to make it so that it didn't do a delete.
Exactly. Yeah, because the default delete functionality is to just execute the delete operator, and that's wrong, because it's not your responsibility to do that.
I see.
So really, it's basically like if we just made that a regular pointer, we could delete all the deleter stuff, and it would just not ever delete it. You could make copies of it. I think the key thing is to make sure that the copy actually does the reference counting. Like it's as if you created a new one, so you need to have the other one be released as well. It's like a new thread has joined that thread
I
save
don't,
function, right?
not necessarily. I don't think just copying the thread save function would mean that you've acquired a new one, because there's a specific API.
Yeah, exactly.
Okay.
Mhm.
So like you have to say, I'm going to use this one in a new thread if there's an API.
Correct. Yeah.
Yeah, exactly. Yeah. I mean, we could certainly tie the two together, but that would, I think that would be, I don't know, that would just be very sort of inflexible, you know, like if
Yeah,
you
no,
make,
it's not if it doesn't.
a copy of it.
If you're not copying it for that reason, then why?
Yeah, exactly. Yeah, because the copy constructor can end up being called like for all kinds of different reasons, and then you're basically just thrashing the ref count at that point.
I mean, I guess the one thing that does need to be clear though is that if you make a copy and on any one of those copies you get the closing, or you call release on any one of those copies, you're done.
Yeah.
Right? Like so the code has to be smart enough to know that, okay, it can't actually call on, it can't use the class to figure that out.
No, but it is kind of tempting to write a mechanism where, you know, you can declare a thread safe function inside a scope and just use like RAII, you know, where you declare that, because, you know, threads are usually simple. They're like, you know, start the function, while true, do something really heavy, and then you know, if something, then break and exit, right?
Mm-hmm.
So at that point, to declare something at the top of the function, which basically results in an acquire, and it results in a release when the object goes out of scope, is very tempting, because that would be a very clean implementation. But I'm not sure if this is capable of that as it is. And that would be what you said, where you know,
Right.
creating the object same as acquire, and when it goes out of scope, it's the same as release.
Yeah, okay, that wasn't quite what I was thinking of, but it's along. Yeah, it's like what I was thinking of. The case is, as soon as you make a copy, even if the copy was using, like, say for some reason the same thread was using two different copies, if either one of those hits, like, it's back to what you were saying though, is you know, you can have code that just goes in a loop and says keep doing this, and maybe there's two different places and that's why you have a copy. I don't know, but you'd like it to just, once it errors out, terminate that flow, right? But if it's not tied to the instance, then you better make sure that if any one of the copies that happens on, you error out, right?
If one of the copies, so for each copy that's made in acquire, each copy has to get either a release call or one of the closing. So, you know, if I've created my original thread save function and I've copied it, then as soon as I've made an acquire, at that point, I really don't care about what's going on with the other threads, because as soon as I do a release or closing or get a closing, then I know that I am done.
Yeah.
But
yeah,
it is a problem
for all the other calls.
Sorry?
I was just saying that and the same thing is true for every call site or for every use site. As long as you bookend your use with acquire and release, and you handle closing, even if it's 15 times in the same thread or it's 15 different threads, it shouldn't matter.
Yeah.
So proper use ensures proper function, basically.
Right.
Now, whether that use is nice and convenient, or whether you have to, you know, write a lot of code like acquire and release, and you have to handle the case of closing all the time, that creates a pattern which may or may not be convenient, but it is correct when used.
Right.
So yeah, I think it's pretty safe to go with that.
And how would we handle like the assignment operator if the wrapper thread safe function already holds a thread safe function, an N-API thread safe function, and you're trying to overwrite it? Like you would end up having a memory leak. But
I guess you could do a release, right?
Well, like what if it's just, I guess, a hypothetical situation here where like you would end up
honestly,
like you would end up having
I was just
sorry, okay, go ahead.
Timing is terrible. Basically, I'm starting to think that this is best used as a pointer. You know, so just new N-API : thread safe function, and then just pass the pointer around, and then you can make any number of copies, and then for any one of those copies, you call acquire, you use it, you call release, and that's it. And then the ref counting happens inside an API core.
Well, but
and then the pointer
in your copies, you don't call. Sorry, you call acquire and release yourself, right?
Okay. Exactly. Yes, and all the copies are pointers to the same object. So, and that's fine, right? And furthermore, all the copies are thread safe, even though you just copy the pointer and you're dereferencing that same pointer, because all the items that you access inside the instance, you access them as read-only, right? So you're never assigning anything inside the instance. You're not changing the state of the instance ever, right? So you don't need to worry about concurrency. All you're doing is reading off the thread safe function all the time and just passing that through to the thread safe function API, and that API will then safely access and modify the state. So you're not ever actually modifying any state inside the C++ instance. So it should be safe.
So what does that bring us down to? Sorry, when you said use it as a pointer, like so, as opposed to be stack allocated, is that what you mean, or?
Well, yeah, basically, yeah, you heap allocate the C++ instance, yes.
Okay, which is not what's done today, is that?
Yeah, I don't know. It might be what's done today. I don't know what does new return.
So where's our news? Oh, these are all new.
Yeah, okay, so that's the problem. It returns, yeah, right now it returns an instance, not a pointer to an instance.
Right.
So then, yeah, I guess that's why we're kind of re-implementing some of the pointer semantics.
But I guess you could, so you could allow it to be okay, here's a copy, but like you said before, the acquire and release are still your responsibility.
Yeah,
correct.
Right? Like, now the only problem is you could, if you don't do the acquire before the giving out the copy, you've got a race condition. Right? Because basically you could say, here's your copy, then immediately the other one finishes and now it's destroyed, and you're going to use it, and it's
yeah.
So it almost needs to be that, like, on a copy you end up doing the acquire, which I think what I was kind of thinking, and then but it would still be up to it's like you've got it's a new one, it's already acquired, you have to release it.
I do have one interesting question though. Like, if this is an instance, then how do you pass this to a thread? Like, my understanding is that most thread libraries, they accept a void star, and they pass that to the entry point of the thread, and that's it. So how then do you pass a n-API thread safe function to the entry point of a thread if that is not a pointer type?
But you're in the same.
Yeah.
I think it's okay if like your outer code starts the thread, because it has its stack allocated, and that outer thing shouldn't go out of scope. Is that right? Until the whole process goes out of scope.
Yeah.
And like you have a main thread which is running. It starts some new threads, and it's basically passing references to its context. Now, I guess even if the thread finishes that main thread, it may not clean up the things that were like, you're not unwinding the stack, right? If you are.
But one of these thread safe functions would be stored inside the stack. Like it will be on the stack, and so you spawn the thread and then you return, and so it will be gone.
No, it's unless you join or something.
Unless I don't know, C++ does some crazy things with when you do like what do you call that? In a lambda function where you do like the ampersand thing, maybe it keeps that stack frame alive somehow. I don't know if C++ does any of that, because the something is still referencing variables in there.
Yeah.
If that something is a thread, I mean, for the sake of correctness, it would probably keep those variables alive. So you would get that for free. In which case, it would be okay to declare them on the stack, on the main thread, and then use a lambda, which is exactly what this use case I think is saying. Like, you can't use this with lambdas because there is no copy constructor. So then I'm assuming that if there were a copy constructor, then C++ would take care of retaining the instance in a valid stack frame for the sake of the thread.
Possibly.
Yeah.
I was just looking at the other problems to make sure they weren't related to what you were just talking about, but it doesn't.
Yeah, here we go. This is mentioned here, I think, in point number 2 in the episode.
Right.
Safe callback classes only factoring. Yeah. Yeah, exactly. Yeah, so yeah, he also wants this to be created on, or the ability to create a thread safe function on the heap. That's point number 2.
Well, it says in the absence of a copy constructor.
Yeah. If there were a copy constructor, this would not be needed because you could just assign things. And to do the ampersand thing for capturing variables. Yeah, okay. Yeah, point number 3, I think, is just a documentation issue.
Yeah.
And we may need to fix the example to actually call acquire and release.
So are we back to, we could make a copy constructor, but the copy needs to increment the reference count, like basically do an acquire.
That would probably be safe because you know, then basically the life cycle of the thread safe function, the core thread safe function, would be tied to the various scopes. But that's good. That's okay. And it's okay to decrement the reference count any number of times. It's not an expensive operation.
No.
Reference counts on average would be higher than if you were to increment them by hand, because you know when you are incrementing because of a new thread and other, whereas when you're incrementing just because of like variable juggling. But that's okay. There's no harm in
Right.
that.
You would have to.
Yeah.
The real impact is you have to potentially release more times, and you have to make sure you do that, or you'll get the memory leak.
Well, I mean, if we tie the acquire to the life cycle of the instance by way of the copy constructor, then we should also tie the release the same way. So that would make sense.
Right.
So
that would be a difference for the new, though, right?
Well,
like,
yeah.
that starts like I think that starts to get more confusing, because it's then like, I've got this thing, do I need to release it or not? Right?
Yeah. Yeah, because we did expose, acquire, and release.
Right.
But you know, I mean, basically, if you call acquire, let's say we do the copy constructor and we do the automatic acquire, right, and the automatic release. If you call explicitly acquire, then you must call explicitly release. Whether or not behind the scenes it calls acquire and release as a pair doesn't really matter. Again, it'll raise the reference count a little bit, but it doesn't matter.
Right. Is there ever a case though where it's going to be hard to force the instance out of scope? Like, you've created this thing, and if you've got to actually delete the object, is that ever going to be an issue? Like, it's on the stack, so you can't just say get rid of this.
That's right.
And you must get rid of that, or else you're not going to free the memory.
Well, I mean, just return, right? And if that is the last stack frame that was referencing it, then that would be the last ref count, and when that exits
right.
the TSFN.
But are there any cases where you've got some code, so it's sort of their main thread code, you're running through some stuff, you've used this stack, you've used the thread safe function, you're not going to use it again, so you want to get rid of it, but you still have other code to run?
Oh, okay, I see what you mean. Like, you don't want to hold up the release of the thread safe function.
Yeah, I don't know if that matters, but that's the case where then that would be harder if we tied it automatically.
Then what I would do is I would create a scope inside my function which needs the thread safe function, and then it goes out of that scope and the rest of your code which doesn't need the thread safe function.
Yeah, that seems, and then people will probably never need to use require, right? Like acquire.
Yeah.
And or release, but you could potentially, if you.
I still don't fully, maybe because I don't use C++ that often. I think more in terms of like plain C. I don't see how if you start a thread, you can pass in anything other than a pointer, you know. And if the N-API thread safe function is not a pointer, how do you pass that into a thread? You know, like, okay, with a lambda function, C++ does some magic whereby you can reference objects from the outside scope even if they're not pointers. Okay, that's great and all. But if you just use like a plain start a thread thing, you know, like there's like a standard thread object, right? Like if you do that, can you still pass in something other than?
You can take the address of something on the stack.
Yeah, I guess. Yeah.
You just better make sure that you don't, make sure it doesn't go out of scope.
Yeah, basically. Okay, well, I'll just have to accept that then.
I know what you're saying. Like, it might be useful to have a pointer, but it seems like that's not done in a lot of the V8 stuff. So, you know, having the stack allocation tends to work.
Yeah.
So yeah, no, I like
Oh.
your see, we can just make it a regular pointer. Creating the copy should increase the reference count. Actually, so I'm going to say we should add we should add acquire on all creates and release on all releases means acquire / release won't called at all, right?
Yeah.
In fact, we may think about getting rid of that.
Well, I mean, when you create your thread safe function, you can specify how many threads are initially using it.
Right.
So you will, at that point, need to use release multiple times.
Okay.
Yeah, that's another thing, right? Like,
I guess that's true if you're sharing the same instance, which you could do.
Correct.
Okay. So yeah, it's really if you okay, that makes sense.
Yeah, we have to remember that this thing can get passed into threads which already exist.
Right.
So you know, but on the other hand, I'm not sure that it can, because if the thread is already running, then you know, and it's one of those fancy C++ threads which, you know, is in a lambda and all that, so then it would have to exist first and then the thread start. Whereas if it's a classical thread, then yeah, you can just use a message passing mechanism to pass a pointer, and at that point you would have to call acquired explicitly.
Oh, so, sorry, I'm 10 minutes late for another meeting. Oh, sorry. Sorry.
But we can keep thinking about this.
Yeah, I think okay, but I think I've taken a few notes there, but yeah, I better run off because I've stood people up. But yeah, I think we kind of got a way forward, right?
Yeah.
Yes.
Okay.
I don't know if though.
We can think a bit about more of it and hopefully talk about it next week.
Yep.
Okay. Bye.
Yep.
All right.
Bye.
All right. Talk to you guys later.
All right. Talk to you later.